Wednesday busy day. So finally, how did you get this? Like how many 2 input? Good morning. So how many 2 input NOS? Yes. Waiting for the answer. Okay, somebody has posted, right? Let me see. Okay, somebody. How many means? Yes. Can 9 is required?
Yes, ma'am. Yes, ma'am. I've done only NAND, ma'am. Nor
Okay,
I've done.
that to 10 days, right? So anybody to support him? See, this is very, very, very bad. Out of 112 people, at least I expected a 50 answers over here. See, if you have done the question, you could have posted me long back. Like yesterday night also I have checked. Nobody has posted. I don't know why. You heard the word CA, right? There is a teacher's assessment. Yes, ma'am. Komalika.
Ma'am, I have done using NOR and NAND gate both.
Both NOR and NAND. Why?
Yes.
Mixture of both.
Yes, ma'am.
Why did you blame your own question, Komalika? It's fine. Okay, so post it. Let's see. See, always remember there are some things which I do believe from the class that with interaction and all, I'll have my own assessment. Okay, so if at all you, if at all you are like this means it's very bad. I will not say it is mandatory. I will have my own rules for that. Okay, teacher's assessment will be within our purview. Okay, so try to do whenever I tell means it is mandatory, but I don't post. So Swapnil Kundu. Okay, Swapnanil. Swapnanil. Okay. Let's see your today somehow the network is very bad. So Swapnil, what do you want to say? You have used 2 input NAND. How many you have used? But nobody has given me the minimized function. So Priya has done both NOR and NAND. So how many gates, Priya?
12. 12.
Okay. See, I don't know the answer to be honest, but question is the minimum the better. The minimum will be the better. Right? So I should see the postings. Okay. So now today I will try to discuss Today I will try to discuss another peculiar terms called. Okay. Till now you are aware of min terms and max terms. Am I audible?
Yes, ma'am.
Okay. So
Yes,
till now you have you know about min terms and max terms, right? Both of them you know that. Like for example, you are telling that like you are trying to do with min terms, you have your rules for that. Max terms, you also have your rules for that. Fine. So you are trying to use this min terms and max terms to frame an expression, that to Boolean expression, and afterwards you will apply some postulates or the K-map techniques to minimize them and get the circuit. So that the circuit will try to explore or try to exhibit some particular function. Is that clear? Correct or not? So now in the next hand, like we are trying to discuss about some functions called don't care functions, right? So don't care terms or don't care, sorry, I should not be using the word functions. I will use the word called don't care terms, right? Now this should be new for you. You might not have heard about this. You heard about this?
Yes, ma'am.
You heard
Yes.
about this. So you can give me your definition before I jump into my definitions.
Ma'am, what we do is that when we construct a
Ma'am,
K
these
map,
are the
we
terms
replace
for
it
which
with X.
output is 1.
One at a time, one at a time.
We generally replace like the don't get terms with X like in the K map, and accordingly we find
No. Wait. Prior to that, who are don't cares?
like we can replace them with 1 and 0. Like means there is no fixed value to that.
No, we didn't replace 1 and 0. What did we do is, min terms are those terms we have framed them with SOP form, right? Indicates we have used, and we are representing 1 for them. And max terms we are framing them as product of sums, and we are terming them as zeros. That is a notation we are following. But what is this you are telling? Who are don't care? First of all, you have to tell who are don't cares.
Ma'am, don't care terms
These
are
are
those terms means uh, on which our function doesn't depend. Means
Okay, correct. So, first point is the function does not depend on those terms, but why they are a part of that function, like why they are existing. If they are not dependent, why they are existing?
They help in reducing the function into a more simpler form.
Okay, they are helping in this. So, to be honest, to explain that, foremost example is we have a BCD code. You remember that in your second semester, first semester, you might have studied BCD code, binary coded decimal.
yes, ma'am.
Yes,
Right.
ma'am.
So now we have the weights like this. Correct? So now we will have from 0 to 9 exclusively given in terms of this. 8429 means 2 power 0, 2 power 1, 2 power 2, 2 power 3. Is that correct? So now when we are using a decimal digit, that means it expresses from 0 to 9. After that also 11 to 15 still we can use here using this particular coding system. But decimal system, sorry, 10 to 15. So decimal system does not have this. Is that correct? Decimal systems are from 0 to 9. 10 to 15 is not a part of the decimal system. But for representing a decimal number, we use minimum 4 bits. Right? So when we have already allocated 4 bits to represent a decimal number, we can still extend from 10 to 15 also, though they are not in the binary coded decimal. Are you clear now?
Yes.
Yes. So now here I will start the conversation. What is that? 0 to 9 is our actually required. 10 is the value which is coming as a complement for bonus for us. Right? So they are a part of the 4 bits representation, but still they are not terming as a input. That means they are coming as a bonus. So should we avail this bonus or not is a wise decision. Right. Now consider we have a 4 variable map. Right. Now they is having some BCD input, right? And they doesn't have so BCD to some XS3 something they have changing. Okay. So I think you might have done. Let's start this as an example. Okay. Take the question. Design a circuit. Design a circuit that converts BCD to XS3. That converts BCD number to XS3. Okay, so whenever such a design is required, prior to that, we have to form the table. What is the table? Truth table which explains this. Now, we have to assign some variables to the BCD. So, I am taking it as W, X, Y, Z. They are the BCDs. Then afterwards, XS3. You heard of the word XS3?
No, ma'am.
No. Okay.
No,
I
ma'am.
can. Okay, no issues. Exercise 3 is a code which is developed from a BCD by adding 0011 to the input. What is that? We are adding simple 3. Exercise 3 we will tell. Exercise 3. Remember that. Exercise 3. This coding, so many codes are there. You have heard about gray code?
Yes, ma'am.
Okay. So no problem. So we can have this and we can have that. Okay, sorry, no, just a second. Huh? Class. That's it. हाँ डिजिटल कर ओके आप क्या बैठ okay so sorry so exercise 3 is a code which is used to convert a BCD by add sorry BCD we have to add 0011 what is this decimal equivalent by the way it is 3 na
3.
3 that's
Yes.
that's why the name called exercise 3 okay so now uh, these are my outputs right so for every decimal digit 1 2 3 4 5 6 7 8 9 okay so first I will write this is BCD this is my exercise 3 okay so for 0 this is 0 exercise 3 will be for this one it is 1 and this will be just add every number with 0011 plus BCD. That's it. Then you will get your exercise. So you can continue. Yeah, I have missed something. 2, this should be 3. 2 plus 3 it will be 5. Okay. 3 plus 3 it will be 6. 4 plus 3 it will be 7. Okay. 5 plus 3 it will be 8. 6 plus 3. 6 plus 3 is 9. 7. 8. Let's watch. That's there is a matter. Done because it clearly the problem says that. Is that clear? How did I frame?
Yes, ma'am.
Yeah.
Yes.
Just adding 001. Right. So now here we have clearly the problem BCD to exercise 3. So BCD numbers are only from this and this one. Right. Now, whenever we are trying to frame the circuit, it will be like this. We have inputs coming. Who are those? W, X, Y, Z. Right. And the outputs are A, B, C, D. Right. And in between is the circuit which is used for conversion. Right. Now clearly understand. Outputs are what? A, B, C, D. Right. That means every output, clearly understand, every output should be linked with all the inputs. Is that correct or not?
Yes.
Every output. Now once this table is ready, this is the call we will say truth table or we will call conventional table or we can say the relation table. Anything we can say. Right. So once the output is ready, what we are trying to do? We are trying to take each output in terms of all inputs. That means the function A, the output function A has to be written in terms of all these things. Clearly understand. That means what I am trying to do. So A is what? Wherever ones are there, I will pick up and make the min terms. Is that correct? So what is this? Midterm 5, 6, 7, 8, 9. Is that correct? Clear?
Yes, ma'am.
Yes. So every output function, wherever one is there, I am taking min terms. You can take max terms also. Max terms means you will get all these zeros, you will take and then collaborate with this. Doesn't matter. You can choose anything to represent. So P of W, X, Y, Z. How much it is? Can you tell me? It is here this one, this one, this one, this one. So its corresponding terms are 1, 2, 3, 4. That's all?
9 also.
Yes.
Yeah. Okay, now how much? See, quickly. How much? See, 0,
0,
0, 3,
3,
4,
3,
7, 8.
4,
4.
7, 8.
0, 3, 4, 7, 8. Good. Now D quickly. D.
0,
Okay.
2,
Okay.
4,
Okay.
6, and 8.
6 and 8. Okay. Good. Right. So now after this, it is a simple minimization problem. Correct? It is a minimization problem. Now, in order to, now see here, till here, whatever we get, it's very easy. Like we are taking the relation between BCD to XS3 and we are writing the problems. Now, here comes the actual task. What is the task? If at all, just think, if at all we are having these numbers, min terms, so we will visualize a 4 variable K map and we will try to pair them or get 4 quadruple or we can get octaves also. Right? Now here we have some helping hands. Who are those? Now, if at all we can see after 9 also, I can write 10. But 10 is not a part of our conversion. Right? But our 4 bits are eligible to use 10 number, can write 11 also, can write 12 also, 13 also, 14, 15. Is that correct? They can be framed, but they are not a part of, yes, go ahead. Yes, somebody is telling something. You're telling something?
No, ma'am.
No, okay. So 10 can be used, 11, 12, 13, 14, 15. Everything can be used. Correct. But they are not asked in the system. Right. So now that is called the bonus. Right. The bonus is we can use another numbers called 10, 11, 12, 13, 14, 15. Now who are those? Who are those? It can be framed, but it is not a part of our system. It can be used, right? It is a part, it is not a part of the input, but it can be utilized because we have the 4 bits ready with us. Right, now hold on. Right, now what did I do here? I used a word called phi. Sigma phi. It is telling that sigma phi are the min terms which are don't cares, that to 10 to 15. Okay, so now 10 to 15 are the terms which are used in our system, but they are not our inputs. First of all, please try to understand why the 10 to 15 are there in that special one. Okay, now each function I will try to take. Now I'll take A. How to determine A? Now I already have the original problem of 5, 6, 7, 8, so I will take that one only. So W, X, Y, Z. Right. So 5, 6, 7, 8. I'm not right. Okay. If you want W. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Right? These are the original ones. Is that correct? According to the problem. Yes or not?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes,
Now
ma'am.
the bonus are 10, 11, 12, 13, 14, 15, which can be utilized, but they are not the part of the input. Okay. So who is 10? 10, 11, 12, 13, 14, 15. Clearly see, I have kept them as crosses. So this the first rule is first identify the numbers or identify the terms, min terms, which are not a part of the system but still can be utilized. Right now, till now I didn't tell you how they can be utilized, but they can be utilized once the K map is framed. Okay, now hold on. For example, we don't have this. Consider I don't have this bonus. Now, how to pair them? So at max, what I can do, I will take this because I don't find any octaves. By this time, you should be able to. So how much I got? How much is my function A? W, then Y bar, then X bar, Y bar, Z cancel out. Okay, another one is W bar, I. Is that correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Now I have another alternative. Right now I'm using a green. Okay. So now I have don't cares. Right now I'm trying to rework the problem so that how the function can be reduced, further reduced. Okay. So now further reduction using the don't cares, and then we will see whether it is good to use this or not. Afterwards only we will take the decision. Okay. So we have here like this. Is that correct? Okay. Now, since this one earlier it has a pair. Now, if you see these adjacent ones are there, now they are trying to help every term. Help every term means for further reduction. Now, if I see, I can frame here an octave, complete octave. This one is there, right? Apart from that, this is adjacent to that. It can be utilized as one. This is adjacent to that. It can be utilized as one. That means the don't cares can change their roles to help the min terms, right? Don't care or what? They are inputs. So, but they are not a part of the system, right? It can take either 1 or 0 depending upon our situation. Since we require here ones, the don't cares all will take the ones. They are presumed they are all taking ones. Okay, so 1, 1, 1, 1, 1, 1 here. But don't write there because they are not the original things. So we are trying to understand that they are all ones. Now tell me, is this frame fine? It is good, no? Octave I got. Right? So now if I
Yes,
see here, yeah, similarly, this one is there. Okay, another quadruple I can get. And that it is a valid one. Right? And if you see here, another quadruple I will get. 3. Okay, now for the reduced one, A equal to how much I am getting? It is W plus. Another one is
Exact plus xy.
excellent one. X, Y. Y won't be exact. Plus X,
Xy.
super. Right? Now compare this green A and the black A. Don't you see this function is further reduced when compared to this? Just because I have a bonus points here. I have utilized that. See, it's up to you. You go to shop and then whether you want to use the old bonus or not, that is up to your choice. Now we are getting benefit means we will use. Otherwise, we will retain that. It's a normal practice. Is that correct? Similarly, here also what we do, we are trying to utilize the don't care functions so that we can further reduce. Right? Now the questions you can start. What is the questions? Maybe first question will be, can these be utilized in the max terms also? The answer is yes. So that time the same locations will be there, same locations, but they will be used as a zeros. Are you able to understand? The cross values, either they can take it as 1 or it can be 0, depending upon your requirement, whether you want a midterm or a max term. Clearly understand. That means in our truth table, in our table first, 10 to 15, they are all cross. You can write and keep it ready. So that every function, now another question might be, can this don't case be as used for B? Yes. They can be used for C. Yes. They can be used for D. Yes. Now, there is also another clause. Not necessary. Every time we use the don't case, you will have a further reduction. Okay, now same idea, I think mostly it should be clear. Same idea you extend to B. Get me the reduced term of B. Use don't cares. I should get the answer. At least answer you should tell me. Quickly.
Hello, ma'am.
Yes, ma'am, here only.
Ma'am, I got the answer as x bar y. Ma'am, I got the answer.
Yeah, x bar y. Yeah, go ahead. So for B, na?
Yes, ma'am.
X bar y
Plus x bar z
bar z.
plus x y bar z bar.
X y bar z bar. Okay, now let's see whether it's correct or not. Somebody has told this one. So you have used don't guess or didn't use?
Ma'am, used, ma'am. I have used.
Yeah. Okay, let me verify. Okay. X. So now B is what? 1, 2, 3. Okay. 6, 7. That's it. Okay. So don't guess now. So now let's start utilizing them. So at max, first thing is I will get a this here, right? Then what else? I can have multiple answers, I think here, right? This one. Or I can get a 4 here. देखो गिराएगा क्या?
Ma'am, we can get a 4, upper 2 and lower 2.
That's what I was saying.
Yes,
I
ma'am.
can get a 4. So maximum utilization for 4. First, that only we should aim. For this 4 thing, another 4 is fine. Each minterm has to be aimed for 4 quadruple.
Yes, ma'am.
If not possible, first octave, then quadruple, then pair. Yeah. Can I get a 4 and that should be valid also? I think yes.
Yes, ma'am.
Yeah. Okay. Then what about this? At max pair only. Correct?
Yes.
At max. Yeah. I think this is the possible solution. So, 3 quadruples and 1 pair.
Ma'am, it can be further simplified.
Further, yes, go ahead.
Ma'am, no need of that 13, 15, 9 and 11. That
Yes, ma'am.
quadruple consisting of 13,
Yes,
15,
That
ma'am.
9 and 11.
quadruple,
That
no,
is
there is no
extra.
need of is extra. Yes, ma'am. Two quadruples and one double.
Yeah,
Yes, ma'am.
yeah. Correct?
Yes, ma'am.
So we are getting two quadruples and a double. This is the best choice. Somebody is posting? Yeah, no problem. Right. So I think it will work out. Two quadruples means definitely you will be having this for two quadruples and one pair. Yeah, I think this is the best solution. Right. Is that correct? Now you are able to use the don't cares and able to do, right? Now do for C and similarly for D. Do for C and similarly for D.
Uh, I have a doubt, ma'am.
Yes, yes, go ahead.
I want to ask that when we use don't care or when we don't use don't care, we generally get different expressions of our function.
Correct.
But when we put the values and we get the output should be same.
Correct. Correct.
Is it correct?
Yes, 100%.
Okay, ma'am.
So practically I will tell you what is that. So when these terms are taken, that means this has to be like you take a system, right? You have three inputs, right? And a function will be there. Okay, so that means three inputs, three toggle switches are there, and then we will have the middle circuit, whatever you have minimized and kept, right? And we have a LED at the end. You are able to understand now, visualize it. Is that correct? Hello?
Yes, ma'am.
Right.
Yes,
So
ma'am.
now we have three toggle switches, right? We have a circuit in between, whatever end gates, or gates, whatever you have framed, and we have an LED at the output. So in order to verify, cross-verify or validate your function, what you will do? You will try to change your logic switches. Logic switches means what? Again, you have to convert that back to canonical form and then try to check out whether your LED is glowing for that particular set. Is that correct? So here, when you do this verification of A, 5, 6, 7, 8, 9 combinations, whatever you take, the switch A has to be, output LED has to glow. For the rest of the things, it has to be off. Is that correct? That is how validation is done. Just try to verify. Think, what is that we are trying to do? We are trying to verify. We are trying to verify what? We are trying to verify a function. So practically for this inputs only it has to glow. Rest of the inputs it should not glow. That's what. So for 1 it should not glow. For 2 it should not glow. For 3 it should not glow. Is that correct? Why no response?
Yes, ma'am.
Yes, ma'am. Okay, you are posting. And posting is not now. Okay, see for this one. Okay. For C it is like this. Where okay, Samai? Very good. For D it is Z bar. Oh, super. So for D it is maximum utilized I think. Samai has wrote. Yeah, good.
Same answer.
Yeah. For D it is maximum
Yes, ma'am.
utilized.
Same answer.
Yeah, good. Okay, so no problem. So the don't care functions normally whenever we want to verify them, we use them in the practical situations, whether we want that or not. Right. So since you are not exposed to the practical things, now whatever hard effort I put, you will not be able to understand unless I show you on the breadboard. Okay, so for time being, keep that as a question mark. So whatever it is, it's the truth I'm telling. You can use the don't cares, right? So the cross verification, I don't know who has asked me. What is his name? Come again. Somebody asked me about this. Yeah. So for whoever it is, like he has to understand that we have whatever inputs we have to cross verify that we can do that. We can do that, right? So though you take or the don't cares or not utilize the don't cares, we have to get the minimized. That is the concept right now. Right now we are going with that. Okay. Now in D it seems how much you got? Somebody has posted. It is
Z bar.
Z. Yeah, Z bar. Okay. Somebody has posted. It is Z bar. Is that correct? Is that correct or not? Okay. So now a small thing. Okay. So now we have 15 minutes and we can complete the next session. Next task. Right. Till 4 variables using don't cares or without using don't cares, you are able to minimize. Right. If the question goes to 5 variables, so how we are planning to do? How exactly we are planning to do? Right. So I was telling that we have a tabulation method for it. Is that correct?
Yes.
So how the tabulation function works, right? So let me take a problem for that and then try to explain. How many of you have any idea of the tabulation method? Anybody? Okay. So I need some examples. I was just searching for book. I'm so sorry. Where did I read the book? I don't know. No, no. Okay, for time being, I'll take a normal problem. There's some problem there. Okay, right. Okay, right. It's called. I thought I would work out a problem. See, anyway, we can have 100 problems, no problem, no issue. Incorrect. This tabulation method is proposed by Quan McCluskey. Quan McCluskey. He is the one who proposed it. So, what did he do is, if at all more than 4 variables are provided to us and we wanted to minimize it without using K-max, then he has explained a procedure. What he is trying to do? He is trying to segregate the things who are one step distance from each other. Then afterwards, try to pair them and then finally end at the conclusion. Towards the end, they will conclude like we are trying to pair. Then afterwards, we are trying to avoid some variables used, and then afterwards, we will further minimize. Okay, so for that, we will try to take one problem, right? One problem we will take. So let us consider, just a second, ma'am. I'm trying to find one problem. No, where I am getting one problem. Yes. Now I can get one. Okay. Okay. Now here A, B, C, D, E. Okay. A function A, B, C, D, E is provided. Okay. How many variables? 5 variables. Right. The minterms provided in that are, just a second, 0, 2, 3, 6, 7, 8. 0, 2, 3, 6, 7, 8. Then, I'm so sorry. 10, 12, 13, 15, then how many we can have? 2.5, no? 2.4.
32.
32, no? That's what. So they gave,
32.
yeah, that's what they gave. 22. So these are the terms provided to us. Okay, right? Now using K-map is fine. 5 variable is a bit tough. Then also we can start with that, right? Like we can do it, but it is very difficult to pair them. So we will go for this Quinn-McCluskey method. What did he do is, he tried to utilize all the terms provided and then try to segregate them based on their number of ones present in each term. Now I will repeat again. These all terms will make up F, right? So first step is try to segregate them. Try to segregate them depending upon the number of ones used in that. Okay, so what is that? What is that supposed to be, right? So now first I will take 0. Okay, term 0. This is term. This is number of ones, right? So this is A, B, C, D. This is the first category. What is that? To represent this term, there are no ones in that. Okay, so I will make it, number of ones in that is completely 0. This is the term used and this is the binary description of that. Okay, this is first set. Right? Now, second set is number of ones should be 1. The number of ones to be represented in the binary, that should be 1. Okay, for example, if you take 2, right? So how many number of ones are there in that? Only 1, na? Only 1. So it falls in this category. So anything else is there like that? I think 8. Next one is 8.
Ma'am, you're not audible.
Ma'am, you're muted, ma'am.
Yes.
No one?
Ma'am.
Okay. So now category 2. So number of ones to be utilized should be 2 numbers. Like I am in incremental mode. So I can use now 3. Then afterwards, I think 6 also comes. I am following the sequence only so that I should not forget anything. 6 is what? Then afterwards, okay, who are done, I will cut. 0 is done, 2 is done, then 3 is done, 6 is done, 8 is done. Now 10 also. 10 should be. Right? Then 12. I think correct? Who else?
Yes,
Please
ma'am.
help me out. Then who else?
Yes, ma'am.
I'm 18.
Excellent. 18. 2 power 4, 16. Correct?
Ma'am, can you
Right.
explain
Then
again how are you putting the terms?
what is that, ma? How I am putting the terms?
Yes, ma'am.
Who asked that? See, I am only using number of ones used here are 2 only. Na? See, if you check every term here, what I segregated, they have only 2 number of ones.
Okay,
Any
number of
coefficient.
ones. Okay, ma'am.
Number of ones. Number of ones. Okay. Then who else? 19? 19 comes? No. Correct? 19 comes? No. 22? 22.
No, ma'am.
25. 28.
No, ma'am.
No. Right. Okay. So, yeah. Then we can go for 3. Number of ones should be 3. You should be fast now. Right? Like that, everything you categorize.
7.
7.
7,
Yeah.
30.
3 is 7. Good. Right.
30.
Then
9.
13.
13.
9 is not there.
Yes.
13. 13.
Then 15.
15.
15, na?
Yes, ma'am.
15. How?
No, ma'am. 15 is 4.
No, ma'am.
No, ma'am.
15
15 will be 4.
No, ma'am.
So
15.
15 has 4 ones.
19.
19.
19.
19.
19.
19 is 19 is what? 16,
25.
17, 9. No, wait.
25.
10011.
Yeah. Then 25. 22.
No, ma'am.
25 is what? 16.
16, 8, 1.
Is that fine?
Yes, ma'am.
Okay. Then 25 is done.
31.
31. Okay. What about rest? 31 what?
21. Not
16 plus 8. 24.
And
24
28.
plus
And 28.
28 also?
Yes,
See,
ma'am.
I'll go see.
Yes.
28 is how much?
1110.
16, 8, 4.
No. 8 plus 4, no? Right? 28. Then who else?
Ma'am, 22
Huh?
will come also, no?
How?
22 will 10110.
Yes, ma'am. 16, 4, 2.
10110. And 16? Let's
4.
go. Yeah. 22, that's what. 22. I'm just keeping the sequence now because I should not. Okay. Then 28 is done. Right. Then who else is left? 30 and 31?
15 and 18, ma'am.
Yeah, 15, 18, 30, 31. So how many ones will be there in that? 15 is 4.
31, 5.
31 can come here?
5, ma'am.
Yeah.
31 is
And
So
both are
now,
5.
I think now that. So four numbers. 4 number of ones?
30.
15.
Yes, ma'am.
13 is
15 and.
already done. 15 is what?
No, ma'am. I'm saying 30. 30.
Ma'am, 15 is 1111.
Yeah, that is
Will be
done now. 4 number of ones. I
4,
have
1,
kept in the next category.
8, 4, 2,
4
1, 1.
number of ones. Then afterwards,
30.
18,
No,
18.
18 is done.
Ma'am, 18
19.
comes in 2.
Sorry. 18 is done. No, sorry. 18 is done. I have not done. 18
Ma'am,
is
next is
And
30.
30.
30 only. Yeah.
Yes,
30 is
ma'am.
what? 16. That's 8.
842.
Correct? So now this is actually not there. So I am writing 5 ones will be there. So the term 31 will be there. Then afterwards we will have what? 31 is what? 1.
What?
5 ones
I'm
should be
all
there.
one.
5 1.
All are one.
5 ones.
Right? Okay. So for example, just to reduce, I am removing this one now. Okay, because my board is finished. Okay, right. So like this we are segregating. Now in our problem 31 is not there. Right. So this is our first step. First step, again I want to repeat. Given the number of terms, we will segregate them depending upon the number of ones in that. Okay. So now what is the next option? Next option is, see, always remember, try to frame this so that you will not miss any term. Out of what? Quickly you will be doing, so you will miss out terms. Right. So next thing is, we will try to do a pairing. Now what does a pair means? Now pairing means what? Each set we will try to compare with every other set, so that can they be paired or not. Now in our earlier classes, when we are trying to pair, what we are trying to follow? We are trying to follow one step distance. No? That means one change is allowed. Okay, so now let us consider, can we pair 0 with 1? Can we pair 0 with 1? Sorry, 0 with 1 means 0 with 2. Here, 0 with 2 and 0 with 8 can be paired. Yes, it can be paired. Why? Because see, 0 with 2 and 0 with 8 can be done. So I will just have a mark here and then B, C, D, E. What happened? This pair 0, 0, 0. Which position is changed? I kept one blank there because to indicate that there the change is happening. 0, 8. This is the change. Did you understand? How did I do? Did you understand how this pair has come?
And bar
0,
in the
2.
place of where change is happening.
What?
And bar in the place of where change will happen.
Yes. We are keeping a bar where the happening change is happening there. Correct. Is that correct? Easy? Right. So don't forget, we have to compare with everything. So this one, with this complete set. See, there are 2 changes required. So it is not in our system. From here to here, 3 changes required. I don't want. This one to this one, 4 changes are required. I don't want. So complete pairing is happening from one set with the next one only for this particular problem. Right. So similarly, again the pairing starts from with this. Yes.
Ma'am, and
Yeah.
when you are saying that one change will be there, it means the difference will be one, or one digit will be different.
One digit, one particular bit change is accepted. One bit change is accepted.
Okay.
One bit change is accepted. Any position doesn't matter, but one bit change has to be taking place. Clear?
Yes, ma'am.
So similarly, with 1 and 2, that means number of ones 1 and 2, this 2 sets. So can I make a pair 2 with what? 2 with 3 can be paired.
3 and 6.
Correct?
3
3,
and
6, 10, 18. 3, 6, 10,
No, you are telling me the answer. 2, 3. See, I'll take one at a time. 2 and 3. 0, 0, 0,
1, 1.
2, 3. Correct? See, I should be very particular with the blank because the next one depends on this. 2, 3 is done. So 2, 6. Yes, I can get 2, 6 also. 2 and 6. So we will get so many, I guess.
yes, ma'am. 2
2 with
2
6 is done. 2 with 10. Yeah.
yes, ma'am.
2, 10. Yeah, that's what. 2 and 10. How much?
0 bar.
0 bar 0 1 0.
Bar 1 0 bar 0 1 0.
2 and 12?
No, ma'am.
No, ma'am.
2 and 18.
No.
Yes, ma'am.
Yeah.
Yes, ma'am.
So 2 and 18, it is
That bar 0010.
right. So now 2 with everything is done. Similarly, 8 with next we have to do. 8 with next one we have to do. So with 8, I keep on erasing. So you people also can use pencil instead of pen. So 8 with what? 8 with the next one.
8 with 10 and 12.
8 and 10. 8 and 10. So 8 and 10. Just check. Correct? And 8 and 12.
Yes, ma'am. 0 1
Yes.
bar 0.
Right? And 8 and 18.
No.
No, ma'am.
8 with 2 also nothing. So there's no tick here. So have a mark that 18 is not paired with anyone yet. Okay. Right? So till here, I think this is closed. This comparison is closed. Correct? Right. So now this with this comparison. Oh, by the way, wait. With this one to this one and this one to this. Sorry. Where are we? These two are comparing. Na? So with this next to next. Combinations. 2 and 3 combinations. 3 and 4 combinations. Please list out. So that everything should be ticked. Please list out the combinations. You have a class next 11 to?
No, ma'am.
No. Okay. Can we continue or we will stop?
We can continue.
You can continue?
Yes.
Okay. So we can, yeah, you please complete the pairings. So next combinations, anything we will get? See, the combination
Yes, ma'am.
pairings we
3
have,
7.
yeah, pairings we,
3 7
yes,
3
ma'am.
19.
3 7
3
3
7
19.
3 19.
Okay, 3 7. So I will believe 3 7 3 19.
19.
Then
6 22.
6 22.
Yes, ma'am. 622.
That's all. See, 3 with this one, 3 with everything, 6 with everything, 10 with everything, 12 with everything, 18 with everything.
12 and 28.
Okay, no, don't go with 12 and 28. 6 with respect to all also combinations we should take. We should not omit anything. All combinations we have to use.
Ma'am, 6
All
only with
combinations.
22.
I'm 6 7.
6 and 7.
6 and
Yes,
7.
ma'am.
Okay, 6 and 7. Then 6 and 6 and 7.
6 7 6 22. 6 is over.
Yes,
Okay,
ma'am.
6 is
6 is
over. Okay. Over. Okay. Then what next? Then 10 with anything?
No, ma'am.
No.
no,
Okay.
ma'am.
It's a fine. So 10 with anything is nothing is there. 12 with anything?
12
12
7
28.
12 13.
12 and 28.
Yes, ma'am. Yeah.
12.
12 13 and 12 20.
12 13 first.
12 13
12,
also.
13 and 12 and 13.
12 28.
12 and 28. Somebody cross verify it also. I'm blindly believing you. I'm worried about 25 and 18 because they are
18
not used one.
Ma'am,
18
18
what?
and
18 with
22.
nothing?
18 19, ma'am.
Yes, ma'am.
18, 19. Yes.
Yes, ma'am. And 22
Fine.
also.
18, 19.
18 22.
At least once they have to be utilized. Okay, I'm worried out. Okay, 25. What about 25 is fit? Done?
Ma'am, can we use 22 with both 6 and 18?
What do you mean by that? 22 with both things means? What do you mean by 22 with both things? Can you please
Uh,
elaborate?
both means when we are taking for 6, we write 6 and 22. And for 18 also there is 18 and 22.
Yeah, you can use, no problem. See, in our K maps, are we not using the same min term to map? They are still valid, no?
Okay, ma'am. Yes, ma'am.
Yes, like that only, visualize that.
Ma'am, 28, 30 also.
28, 30. Oh, you went to 3 and 4 already?
Yes, ma'am, because 3 is over, I think.
No, I think 25 is left out. Oh,
Okay.
what is the next one you got?
Cannot be
7,
paired.
7, 15. 7, 15.
7, 15. Okay, 7, 15. Then what else? 7, 15 and somebody told 13 something? 13, 15?
Ma'am, 22,
13,
30
15
also.
also?
Yes, ma'am.
Yes.
13, 15.
13, 15 also. 22, 30 also.
22, 30. That's all? That's it? Anything else? So other
28,
than 25, everyone are utilized, correct?
ma'am, 28, 30 also.
28, 30. Okay, good. Don't miss anything. 28, 30. 28, 30.
Yes.
Done? Almost.
Yes,
See, in
ma'am.
the last
Yes, ma'am.
3-4 comparison,
30,
we got this
31,
many.
15, 30.
31 is not there. 31 is not there. I have removed. Correct? Is that fine?
Yes.
Yes. Yes.
Yes, ma'am.
So now what happened? Now our second step is over. What is that? The combinations. Pairing is already done. That means we allowed one change. What is that? Wherever the change is there, we are keeping a hyphen or a blank. Is that correct?
Yes, ma'am.
Right? Right. And we have a cross question, a cross check also. We are trying to tick it. By the way, these are all utilized. So we found one term is not paired with anything. So please remember. Otherwise, keep a mark. 25 is never paired. Keep a mark for that. Okay. Now, the third part. 22, 30, 28, 30. So the third one. Any guesses? Any guesses? Now by this time you should be able to understand what is happening. When we are merging two terms, we are getting one blank. So the next level will be, we will have two blanks. Correct?
2-bit difference.
2-bit difference.
Yes, 2-bit difference we can entertain. Why? Just hold on. We cannot do like that. So we will try to compare, right? First and foremost thing is the blank positions should be same because already established blanks are there. For example, if you are pairing 08 with 210, just see the blank position 08 and 210. They are both at the same place, right? One more change is allowed. So for me, 08 to 10. If you take 08 with 210, 08 with 210, I have already a 0. One blank is established, 0. Another blank newly formed, and next is 0. Is that correct? 08 to 10.
0,
So
2,
this is
10.
already there. Yes. One more blank is allowed. 2 step difference. Right. Similarly, 02 With anybody?
8, 10.
10, 10. Same thing. 0 to 8, 10. Same thing. These all turns out to be same only. We can submerge it. 0 hyphen. Right? So just keep it tick. Right. So anything else? Anything else? Nothing, I guess. Because first check the blank position. They have to match. Once they match, then we can do the next alteration. So I don't think you have any matching. I think it's done. Right. So this is done. Then afterwards, go with this one, with this one. Then go with this one to next one. So that in your checklist here, all 2 blanks are allowed. I will repeat again. So you will continue filling up this one, having 2 blanks. Right? No problem. You have 0, 8 to 1, 0 to 8, 10. Sorry, 0, 8 to 10 and 0 to 8, 10. All are same only, but still you fill up. And then don't forget to tick if at all you are using it. Got it? So the second level is like that. Now still further, we can go to the third level. Right? So now please complete till the whichever level possibility is there. So each tabulation. I think it's better if you keep your book in the landscape mode, rework there and then nicely post. Okay, so what level you can do? You can do. Right. So I will do it and post it for you, no problem. But still I expect the students to do. Right. This one, this one, this one, this one. Next level also you go. If at all finished, next level also you go. There you hold on. Is that fine? I have a meeting now. Right. So can I leave?
Ma'am, is
Yeah.
this also possible using a 8 into 4 K-map?
What is that? What is that?
8 into 4 K-map.
I'm not able to listen. Somebody is asking me something. Somebody is asking something. Please tell.
Yes, ma'am. I was asking, is this also possible using K-map?
Ma'am, he's asking 5 variable K-map.
Yes,
Yes, ma'am.
possible. This is 5 variable. Now next time I use 6 variable.
Yes, ma'am. Means 8 into 4 K-map. Means 3 variables in one side, 2 variables in other side.
See, you can use KMAS, but we expect you to do this method, Kwan-McCluskey method. I'm not denying KMAP should not be used, but Kwan-McCluskey is authorized.
Ma'am, after
Okay,
this,
so
excuse me, ma'am. Ma'am, after this tabulation, like what is the conclusion? After doing this tabulation, what is the conclusion? How are we reducing it actually?
I'm so sorry, my voice is breaking.
Ma'am, after this tabulation, what is the conclusion? I mean, what?
No conclusion yet. No conclusion yet. So we will try to place 4 terms together, 2 terms together, then 6 terms together. 6 is not possible. Octaves, right? This is quadruples. These are pairs. Correct. So now, next task will be what? Just see. I'll tell you. Next, for example, you will be having 8 terms. Is that correct? That time, how many will be there? You will be having 3 dashes. Something like that. 3 blanks are allowed, no?
Yes, ma'am.
Whoever asks, please respond.
Yes, ma'am. Yes, ma'am.
Yeah. So you have 3 blanks allowed. Then you have 4 blanks allowed. 4 blanks possibility is there.
Yes, ma'am.
Yes, ma'am.
Right? Correct. So what we are trying to do, whenever we are trying to keep a blank means that much variable is reduced. Okay, now for example, we are trying to do this one. Okay, so finally, what will write this one? A, B, C, D, E. So we will write A bar, C bar, E bar. This is what. These blanks are out. They are merged. So we will try to frame whichever possibilities are there. We will try to map them. Then we will try to map them and then try to reduce the terms in that. That is what we are trying to do. So go on till you get a further reduction. and then have a look back. 25 is not used. It has to be a part of the system. Right? You might be getting some more pairs which are not used. That also should be a part of the system. That's why I'm always keeping ticks, check marks. Every check mark is a point. What it is doing, it is trying to compare. Did you understand?
Yes, ma'am.
Yeah, that's what. So you keep continuing that and then finally get the function. That's what. Each function is nothing but the reduced version of the variables. Nothing more than that. Okay, so
Ma'am,
utilized or not utilized? Yes.
ma'am, I want to ask that when we have a simpler method like K-map, so why are we using this method to solve? What is the significance of this method?
Your voice is not audible now. Your voice is having a lot of drops.
I am asking that when we have a simpler method like
Please type.
K-map,
Please type the question. Answer. I mean, whatever question you have, you type. Type the question. So swallow. When we have a simpler method like K-map, then what is the significance of this method? Okay. If you have 10 variables, how you will reduce? Can you imagine that many things? Yes, Varun?
yes, ma'am. Means by this method we can reduce any number of variables, but
Yeah,
with
that's
help
what. No, more than, yeah, that's what. See, the tabulation method comes into picture where we don't have an option to visualize a graph. Okay, the graph two-dimensional version, that to 4 also I have fit. Fifth variable is again a combination that becomes a little tedious. Then sixth variable is impossible, at least for my level. Okay, so you can visualize that it is like hyper-dimensional you are going. Okay.
yes, understood.
Right. So please continue this one and then final answer. Right. Even if it is wrong, also you please post it the full form. I want to see every point. Like take a fresh page, put it in the landscape. Try to include every term and then keep the tick marks neatly done. Okay. I expect everyone has to submit this. Okay. I'll check everybody's. Got it? Okay. So I'm so sorry. I have a meeting to attend now. Continuous calls are going on. Right. I'll continue tomorrow. Okay?
Okay, ma'am.
Thank you, 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 ma'am.